डीएनए फिंगरप्रिंटिंग पर हम लोगों ने शुरू की थी। ओके, सो डीएनए फिंगरप्रिंटिंग, व्हाट इज द डीएनए फिंगरप्रिंटिंग? आई टोल्ड यू। अच्छा कि कल मैंने आप लोगों को बताया था कि आपको कोई भी बॉडी का पार्ट जो है वो मिल जाए जिसके अंदर जो है वो हेयर हो, ठीक है जी। दूसरी चीज ब्लड हो, तीसरी चीज स्किन के सेल्स हो, और चौथी चीज चीक सेल्स हो, ठीक है जी। सो ऑल दीज आर द डिफरेंट बॉडी पार्ट्स। इन बॉडी पार्ट्स को अगर आपको मिल जाता है तो इनको हम लोग एक मशीन में डालते हैं जिसको हम कहते हैं सेंट्रीफ्यूजिंग मशीन। तो सेंट्रीफ्यूजिंग मशीन,
सर इसमें ब्लड को किसके साथ मिक्स करते हैं?
अब किसी के सामने वो सॉल्वेंट भी खास होता है उसके अंदर मिक्स कर देते हैं वो ऑटोमेटिकली। ओके, सेंट्रीफ्यूजिंग मशीन, तो सेंट्रीफ्यूजिंग मशीन जो है उसकी एक पर्टिकुलर स्पीड होती है, तो वो स्पीड की वजह से वी एक्सट्रैक्ट द डीएनए। ओके, जब हमारे पास डीएनए एक्सट्रैक्ट हो जाता है देन वी आर गोइंग टू put the restriction enzymes on it. Okay, so restriction enzymes, they are basically the seizers. ओके, ये सीजर्स होते हैं डीएनए के जो डिफरेंट पार्ट्स होते हैं उनको डिफरेंट प्लेसेस से जो है दे आर गोइंग टू ब्रेक देम। ओके, एंड ब्रेक देम एंड फॉर्म द स्मॉल एंड द बिगर पार्ट ऑफ द डीएनए लाइक दैट। ओके, so DNA would change into different fragments of different length. Okay, now what we do, my dear, now we take this DNA sample. So DNA sample की हम लोग करते हैं जेल इलेक्ट्रोफोरेसिस। जेल electrophoresis. But for this gel electrophoresis, my dear, what we do?
सर जो लार्ज और स्मॉल पीसेस होते हैं उनकी हम जनरेट करते हैं।
Whatever the smaller and the larger pieces of the DNA are formed after restriction enzymes. Okay, you do the process of the gel electrophoresis for them. So gel electrophoresis, my dear, इसकी जब करते हैं ये देखें, so this is the gel electrophoresis. Okay, so यहाँ पे gel apply की हुई है। Okay, so you got the positive part up here, the negative part up here. So this is the negative part, this is the positive part. Okay, and then
सर पॉजिटिव इधर नहीं था।
you put the solution, you put the pieces of thread on the pieces of paper and dip them in the buffer solution like that. So this is the buffer solution. Buffer solution. Okay, so buffer solution, I told you normally we take the buffer solution of the pH 8 to 9. Basic pH buffers we normally take. Okay, so pH that is 8 to 9 for this buffer solution. Okay, my dear, now what you do? You should take a hole with the help of the knife. Okay, and put this DNA sample which has been cut from different places by the restriction enzymes up here. So here you put the DNA sample. Okay. Now the DNA sample, my dear, it contains the phosphate group. Have a look up here. What is the phosphate group? P double bond O and O minus. So these groups are present. So keep remember all the DNA pieces, they are negatively charged. They are not positively charged. Keep remember that. Or they are not neutral. They all are negatively charged due to the presence of this negative ion. Okay. So ये phosphate groups जो हैं ये attach होते हैं. So anything which is having more phosphate group with it, so more negative charge on them. So this is the piece of DNA. So it got the phosphate group with it. ओके, तो ये डिपेंड करता है कि उस डीएनए के पीस के ऊपर कितने फॉस्फेट ग्रुप जो है वो अटैच है। जितने फॉस्फेट ग्रुप होंगे उतना उसके ऊपर नेगेटिव चार्ज जो है वो आ जाएगा। ओके, नाउ व्हाट यू डू, DNA sample apply करके you are going to pass the electric current through it. So this is the negative part of the terminal, and this is the positive part of the terminal. Okay. So now anybody could tell me to which place what's up these DNA pieces would travel
But it's positive.
towards the positive side. Why? Because I told you that the DNA pieces. So let's suppose this is the DNA piece. Okay. So DNA pieces, they are negatively charged. Okay. They are basically negatively charged. And why they are negatively charged? Due to the presence of these phosphate group. So phosphate group, uh, now the rate of movement of these DNA pieces, it depends on the length, the MR, the charge on it. Okay. So the rate of movement of DNA pieces, DNA, the first thing, DNA moves towards the positive plate as the phosphate group are negatively charged. Okay. The second thing, my dear, the rate of movement of DNA fragments, it depends on, so I'm going to write up here, depends on number one, the charge on DNA. Okay. The second thing, the MR or length of DNA fragment. And the third part, my dear, that is the current applied. If you apply more current, the rate of movement of the DNA fragments towards the positive plate, that would be very faster. And if the current is less, so the rate of movement, that would be slow. Okay. So now what would happen, guys? So these fragments, they will travel up here and they will form. They are present at different places. They are not visible to us. Okay. Now, what the thing I'm telling you just is, Muskan, just listen it very carefully, beta. You should also listen this thing very carefully. In the DNA fingerprinting, you should know the difference. We have not put any locating agent up here, and they won't become colored by adding any locating agent like nil hydrogen type of the thing. Okay. So these different pieces of the DNA, they are present at different places due to these things. Okay, charge on DNA, length of DNA, and current applied. Okay. Now, when you do the process of the electrophoresis for a particular time, then what you do, you take. Okay, my dear, when you do the process of gel electro after a particular time, what we have to do, we have to sprinkle an isotope of phosphorus 32. Phosphorus 32 means phosphorus 32, and this is the radioisotope. Radioisotope means it gives out the invisible radiations from it. Okay, so you are going to sprinkle the radioisotope up here. Okay, now you know that the DNA pieces, they got the phosphate group on them. So this is phosphate, this is O minus. Okay, so what would happen when you sprinkle the phosphate group with them? So phosphate is going to attach with them like that. So this is the phosphorus 32. Okay, so it would attach on different parts where this negative charge is present, phosphorus 32. Okay, so it will attach with the pieces of the DNA. Okay, Now, what should you do? You should place a photographic film in front of it. Okay? So photographic film, keep remember, I'm going to tell you a story about the photographic film. I think everyone of you are well aware about the X-ray. But sir, do you know the X-ray?
Yes, sir.
So what happens in the X-rays? In the X-rays, they are passed from your body, and there is the photographic film right behind you. Okay. So X-rays, they are able to pass over skin, blood, all these things, but they are unable to pass through the bones. Okay. So what would happen? The X-rays would pass from my body and would strike with the photographic film. So where they strike, at that place, a black spot that is formed. Okay, so they are unable to pass through the bones. So the bones part that would be not black spotted, it become clear, it would become white, it would be white. Okay, so the same thing would happen up here when you place the photographic film up here. The phosphorus 32 radioisotope. Okay, so it will emit the radiations. Okay, so due to the phosphorus 32, don't write it as phosphorus 32 emit radiations. So these radiations strike with photographic film. Okay, and form a pattern of black and white spots. Okay, so where the radiations they strike on the photographic film, at that place a black thing that is being formed. Okay, now my dear, if you analyze the photographic film would be like that. Okay, so let's suppose this is the photographic film. Okay, so this photographic film, it got the different pieces of the DNA would form different spores like that. Okay, okay, so the different shapes of the fragments that is present. So these pieces of the DNA, okay, they would represent a particular pattern. Okay. Now keep remember that 20% of the DNA pieces they are exactly same. Not 20%, 40% of the DNA pieces they are exactly same as mother. So 40% of the DNA is same as mother, and 40% of the DNA that is same as father. Whereas the remaining 20% DNA
Very photographic.
is different, okay, for every individual, for every person, you can say.
ये photographic film है ना?
जी फोटोग्राफिक फिल्म के ऊपर ये ब्लैक और व्हाइट, दीज आर द ब्लैक स्पॉट्स, जहां जहां पे इधर सुनो भाई साहब, जहां से फास्फोरस 32 से रेडिएशन निकलती है ना, सुन लो यार, वहां पे जाके ये ब्लैक कलर के, ये सारे ब्लैक कलर के हैं, बीच में ये व्हाइट है, यहाँ पे भी वो आपके फास्फोरस 32 जाके टकराती, जहां जहां पे वो जाके कोलाइड करेगी तो ये ब्लैक कलर के स्पॉट्स पड़ जाएंगे. सो दीज आर एक्चुअली द डीएनए पीसेस. ओके, और इनका ये जो एक पर्टिकुलर पैटर्न है, ओके, दैट पर्टिकुलर पैटर्न दैट resembles 40% with the mother, 40% with the father, and the brothers and sisters, they are also having the pattern like that. और अगर किसी family को देखें तो उसमें भी कुछ ना कुछ परसेंट 20 और 25% पैटर्न जो है वो रिजेंबल कर रहा होता है, यानी अगर सेम जनरेशन होती है, ठीक है. So this is used to establish the relationship. अब बाहर के मुल्कों में क्या होता है, in the outside countries, you know that when someone is going, someone has done any theft at a place, okay, तो उसका सैंपल ले लेते हैं, सैंपल लेके do the DNA fingerprinting, या whatever the photographic film they got, उसको वो कंप्यूटर में ऐड कर देते हैं, और कंप्यूटर वो डाटे से निकाल के दे देता है कि दिस इज मिस्टर एंडरसन, इसने इतनी बार चोरियां की हैं, ये इतनी बार जेल में रहा है, इसने बैंक लूटा है, तो वो एवरीथिंग वुड बी डिस्प्लेड अप देयर. ओके,
व्हाइट स्पॉट्स क्या रिप्रेजेंट करते हैं?
व्हाइट स्पॉट्स वहां पे कुछ भी नहीं लगेगा ना माय डियर, वहां पे कुछ भी स्ट्राइक नहीं करेगा. व्हेन नथिंग इज गोइंग टू स्ट्राइक अप देयर, सो नो, nothing would be found up there. Okay, so this DNA, this is the DNA fingerprinting. So our electrophoresis topic that has been completed. Okay, so inshallah we will do the chromatography topic inshallah in the next class. Okay, we will start it tomorrow. Okay, some past paper questions. I would suggest you that you should do the past paper questions by yourself. Okay.